close your eyes and imagine a place so remote, so silent, so deeply frozen in time that the wind itself seems to carry whispers from another age. A continent larger than Europe, buried under ice so old it holds trapped air from before human civilization began. This is Antarctica, and tonight we go there.
Chapter 1: The Land That Wasn't Supposed to Exist.
There is something quietly remarkable about the human mind, its insistence that the world must be balanced, symmetrical, and complete. Long before any ship had sailed far enough south to see the ice, long before any explorer had stared into that blinding white horizon, people already believed in Antarctica. They had to. The world, they felt, simply wouldn't make sense without it. This is where our story begins. Not on the ice, not on a ship, but in the ancient minds of philosophers who sat in warm rooms, drew lines on maps, and decided with absolute confidence that a great southern continent must exist. The Greeks gave it a name first. They called the northern sky Arctos, after the Great Bear constellation. And so the land at the opposite end of the world, the land beneath, was called Anti-Arctos, the anti-bear land, Antarctica. They named a continent they had never seen, never approached, never even imagined correctly, and the name stuck for 2,000 years.
Aristotle himself argued the case. He believed that the northern landmasses of Europe and Asia were so heavy, so vast, that the Earth needed something equally large at the south to keep itself from tilting and spinning apart. This was not wild speculation. This was the physics of the ancient world, a logical, internally consistent argument. The universe craved symmetry. Therefore, a great southern continent must exist to balance the great northern ones. He called it the Antipodes, the place of opposite feet. And for centuries, cartographers faithfully drew it onto their maps, a massive southern landmass, sprawling and enormous, labeled Terra Australis Incognita, the unknown southern land. But here is where the history becomes genuinely fascinating and a little humbling. The continent they drew, this enormous land that supposedly stretched almost to the tropics, rich with resources and warmth, bore almost no resemblance to Antarctica at all. It was a fantasy, a philosophical necessity dressed up as geography.
James Cook, the greatest navigator of the 18th century, came the closest. Between 1772 and 1775, he circumnavigated the entire continent without ever seeing it, crossing the Antarctic Circle 3 times. He encountered icebergs the size of cathedrals. He faced storms that shredded his sails and froze his rigging. And he wrote in his journal, with a kind of exhausted certainty, that if a southern continent existed, it was so buried in ice that it would be forever useless to the human race. He was almost right, but not quite, because the continent was there, hiding just beyond his reach, wrapped in its own impossible cold, waiting another 50 years to be seen by human eyes for the very first time. The land that wasn't supposed to exist, the one philosophers invented and explorers kept missing, was real all along. It was simply more extraordinary
and more terrible than anyone had imagined.
Chapter 2: The Map That Broke History. In 1929, a German theologian named Gustav Adolf Deissmann was cataloging a dusty collection of old maps and documents in the library of the Topkapi Palace in Istanbul. It was routine archival work, the kind of quiet, methodical task that rarely produces anything surprising. But on that particular afternoon, folded among forgotten papers, he found something that would quietly unsettle historians for the next 100 years. It was a map drawn on the skin of a gazelle, dated 1513, signed by an Ottoman admiral and cartographer named Piri ibn Haji Mehmet, known to history simply as Piri Reis. The map showed the Atlantic Ocean with remarkable accuracy. It showed the coastlines of Europe, Africa, and the newly discovered Americas in extraordinary detail for its time. But it was the bottom of the map that made scholars stop and stare. There, along the southern edge, was what appeared to be a landmass, a long, sweeping coastline stretching across the bottom of the map. Piri Reis had labeled it and included notes about it in his own hand. And when researchers began comparing that coastline to modern satellite maps of Antarctica without its ice, the resemblance was, depending on who you asked, either astonishing or coincidental. The ice-free coastline of Antarctica, as revealed by modern sonar mapping, shows a geography of bays, inlets, and peninsulas beneath the ice sheet. Some researchers, most famously Professor Charles Hapgood in his 1966 book, Maps of the Ancient Sea Kings, argued that the Piri Reis map matched this subglacial coastline with an accuracy that couldn't be accidental. He concluded that whoever originally surveyed this coastline had done so when Antarctica was free of ice, which by conventional geology was at least 6,000 years before human civilization began.
This is the claim that captured the public imagination, and it deserves a careful, honest look, because the truth is more layered than either the enthusiasts or the debunkers tend to admit. First, what is genuinely true? Piri Reis was a real and accomplished cartographer. His 1513 map is a genuine historical artifact, authenticated beyond any question. He noted in his own writings that he compiled it from approximately 20 older source maps, including, he claimed, maps from the time of Alexander the Great. That detail alone is remarkable. He was working from sources we no longer have access to. Second, what is genuinely uncertain? The southern landmass on his map does not match Antarctica's subglacial coastline as precisely as Hapgood claimed. When cartographers and historians have done rigorous comparisons, the match is partial at best. Some bays align, others don't. The scale is inconsistent in places. The most mainstream explanation is that the southern landmass is a misplaced or speculative extension of South America, a common error in maps of that era, when the full length of South America was still being determined.
But here is where it gets interesting again. Because Piri Reis was not the only cartographer of his era to draw a suggestive southern continent. In 1737, a French geographer named Philippe Bouache published a map of Antarctica, more than 80 years before Antarctica was officially discovered.
that showed the continent divided into two separate land masses by an interior waterway. For 2 centuries, this was considered obvious fantasy. Then, in the 20th century, seismic surveys revealed that Antarctica is in fact divided beneath its ice sheet by a massive subglacial trench. The 2 land masses Buash drew correspond roughly to what the surveys found. How Buash knew this, if he knew it at all rather than guessing, remains unanswered. The honest conclusion is this: the Piri-Reis map does not prove an ancient civilization. It does not prove pre-human survey of Antarctica. But it does prove that medieval cartographers were working from sources we have lost, and that some of those sources contained information we cannot fully account for. That is not a conspiracy. That is simply an unresolved historical question, and those are often the most interesting kind. The map did not break history, but it did leave a crack in it, and through that crack, something cold and old and unresolved continues to quietly breathe.
Chapter 3: The First Men to See the Ice. There is a particular kind of glory that history reserves for the person who arrives first. The first footstep, the first sighting, the first name written into the record. And for Antarctica, for the single moment when human eyes first looked upon that frozen continent, that glory has been disputed, argued over, and quietly contested for more than 200 years. The year was 1820. 3 separate expeditions from 3 separate nations were operating in the waters around Antarctica within weeks of each other. None of them knew the others were there, and each of them at different moments may have seen the continent first. The question of who actually deserves the credit is not a matter of national pride alone. It is a genuinely unresolved historical puzzle, and the answer depends entirely on what you mean by the word saw. The first claimant is Fabian von Bellingshausen, a captain in the Imperial Russian Navy. He was commanding a 2-ship expedition sent south by Tsar Alexander I, partly out of scientific curiosity and partly out of imperial ambition. On the 27th of January 1820, Bellingshausen recorded in his log that he had sighted an ice shelf, a solid, unbroken field of ice that extended beyond the horizon and clearly was not simply sea ice. Modern historians largely agree that what he saw was the edge of the Antarctic continent itself, specifically what we now call the Fimble Ice Shelf.
One day later, just one single day, a British naval officer named Edward Bransfield sailed into the Antarctic Peninsula region and recorded a sighting of mountains and land rising clearly above the ice. His log entries describe what is unmistakably a coastline. Many British historians argue that Bransfield's sighting was the first clear, unambiguous view of actual exposed continental land, rather than an ice shelf that might theoretically be floating. And then there is the American. Nathaniel Palmer was 21 years old, barely more than a boy, commanding a small sealing sloop called the Hero. He was not on a naval expedition. He was not backed by any government. He was a Connecticut sealer looking for new hunting grounds for fur seals, whose populations further north had already been devastated. In November of 1820, Palmer sailed into the Orleans Channel near the Antarctic Peninsula and recorded seeing land. He returned home and told his story, but he had no official log submitted to any government record, which is part of why his claim has always been the most difficult to verify formally. So who was first? The Russians have Bellinghausen, the British have Bransfield, the Americans have Palmer. All three sightings happened within the same 10-month window. And the honest answer? The answer that historians who have studied this most carefully tend to arrive at, is that we genuinely do not know with certainty. The definition of first sighting matters enormously. First sight of the ice shelf? Bellinghausen. First clear sight of exposed land? Probably Bransfield. First American? Palmer.
But there is another layer to this story that rarely gets told. Long before any of these three men arrived, the waters around the Antarctic Peninsula had already been quietly visited by sealers, mostly British and American, who had no interest whatsoever in geographical glory. They wanted seal pelts, and they kept their hunting grounds secret because in the brutal economics of the sealing industry, sharing your location meant sharing your profits. Some historians believe that anonymous sealers may have seen the Antarctic coast years before 1820, recorded nothing officially, told no one, and simply gone home with their cargo. Their silence was commercially motivated, and so the discovery of an entire continent may have been kept secret, not by governments, not by conspiracies, but by ordinary working men protecting their livelihoods. History is full of people who saw remarkable things and said nothing. The sealers of the early 1800s may be among the most consequential of them. Antarctica, it seems, has always resisted being found easily. Even when people were standing at its very edge, looking directly at it, the record of that moment remained uncertain, contested, and incomplete. The continent that took 2,000 years to find managed, even in the moment of its discovery, to remain just slightly out of reach. Chapter 4: A Continent Alive. Before the ice. Close your eyes for a moment and try to imagine Antarctica as it once was. Not the blinding white wilderness it is today. Not the howling sub-zero darkness of its winter. Imagine instead a warm, green, living place. A continent of rivers and forests, and creatures moving through long summer days. A land where the air smelled of soil and rain and growing things. This is not fantasy. This is not mythology or wishful thinking, or the kind of speculation that belongs in the margins of old maps. This is what the science tells us, clearly and without ambiguity. Antarctica was once alive. Genuinely, abundantly, extraordinarily alive. And the story of how it died, how it was slowly buried under 2 miles of ice, is one of the most dramatic geological stories on Earth. To understand it, you have to travel back in time. A long way back. Around 500 million years ago, Antarctica was actually part of a vast supercontinent called Gondwana, which included what is now South America, Africa, India, Australia, and the Arabian Peninsula. All of these landmasses were fused together in a single enormous whole, and Antarctica sat at its heart. During this period, Antarctica was not at the South Pole.
it was elsewhere entirely, drifting on the slow conveyor belt of tectonic plates.
Gondwana began breaking apart roughly 180 million years ago. The pieces drifted slowly away from each other, moving at roughly the speed your fingernails grow, a few centimeters per year. But over millions of years, those centimeters add up to oceans. India drifted north and eventually crashed into Asia, throwing up the Himalayas. South America pulled away. Australia separated, and Antarctica drifted south, slowly, inexorably, toward the pole. For a very long time, even as it drifted southward, Antarctica remained warm enough to support life. The fossils tell us this with stunning clarity. Paleontologists working in Antarctica have found the fossilized remains of forests, actual trees, with growth rings in their wood, suggesting they experienced seasons. They have found the fossils of dinosaurs, several species, including a creature called Cryolophosaurus, which translates rather wonderfully as the frozen crested lizard, roamed across Antarctica during the Jurassic period, when the continent was still warm enough to sustain them. They have found fossilized ferns, fossilized freshwater fish, the remains of creatures that lived in warm, shallow seas that no longer exist. And more recently, in 2020, researchers drilling into Antarctic sediment found fossilized forest roots from roughly 90 million years ago, a temperate rainforest, not unlike the forests of New Zealand today, sitting at roughly 82 degrees south latitude. This means that even deep in what is now the polar region, during the Cretaceous period, the climate was warm enough for dense forest growth. Average temperatures were estimated at around 12 degrees Celsius in winter.
The freezing happened gradually. As Antarctica drifted to the pole and the other continents pulled away, a crucial change occurred in the ocean currents. The Drake Passage opened between Antarctica and South America, and the Antarctic circumpolar current began to flow, a vast ring of ocean water circling the continent, isolating it thermally from the warmer waters to the north. This current acts like a moat. It prevents warm water from reaching Antarctica and locks the continent inside its own cold. Ice began forming on Antarctica's mountains around 34 million years ago. It spread slowly at first, then more rapidly as the ice itself began reflecting sunlight back into space, accelerating its own growth in a feedback loop. By around 15 million years ago, much of the continent was glaciated. By 3 million years ago, the ice sheet was roughly the size and depth it is today. Everything that lived there was buried. The forests, the rivers, the dinosaurs, long extinct by then, but their fossils sealed beneath the accumulating weight of centuries of snowfall, compressed into ice, pressed deeper and deeper toward the bedrock.
And here is the question that sits quietly beneath all of this science. The question that researchers don't always say out loud, but that anyone paying attention begins to ask. If Antarctica was warm and forested and alive as recently as 90 million years ago, and if, separately, the Peary Race Map and other ancient documents hint at human knowledge of an ice-free coastline, then the timeline of when the continent fully froze is crucial. Most mainstream science places full glaciation well before any human beings existed, but the edges of that timeline, The question of whether some coastal regions remained accessible longer than others, those edges are still being refined. What was buried when the ice came? The fossils say forests and dinosaurs. The geology says rivers and lakes, now sealed in darkness beneath 2 miles of frozen weight. And somewhere beneath it all, the bedrock of a continent that was once as warm and loud with life as any jungle on Earth.
Chapter 5. The Heroic Age. Amundsen, Scott, and the Race to the Pole.
There are stories in history that feel almost too large for the page, stories where the scale of human ambition and the weight of human suffering press against the boundaries of what seems possible. The race to the South Pole in 1911 is one of those stories. It has been told many times, but it has rarely been told completely, because the most important details are often the quietest ones, buried beneath the drama of triumph and tragedy. By the early 1900s, Antarctica had become the last great geographical prize on Earth. The North Pole had been claimed, or at least convincingly enough claimed, by Robert Peary in 1909. The interior of Africa had been mapped. The Amazon had been explored. But the South Pole, the absolute bottom of the world, remained untouched. And 2 men from 2 very different cultures, with 2 very different philosophies, set out to reach it within weeks of each other. Roald Amundsen was Norwegian. He was 40 years old in 1911, already an experienced polar explorer who had spent the winter of 1898 trapped in Antarctic pack ice during the Belgica expedition. He had led the first successful navigation of the Northwest Passage. He was methodical, unsentimental, and possessed of a kind of cold, clear genius for logistics. He thought about polar travel the way a chess master thinks about a game, many moves ahead, accounting for every contingency, leaving nothing to chance that could be controlled. Robert Falcon Scott was British. He was a Royal Navy officer, 43 years old, deeply respected, deeply sincere, and driven by a combination of genuine scientific curiosity and the particular weight of national expectation that the British Empire placed on its explorers in that era. He was not incompetent, a persistent misconception, but he was operating within a tradition that valued courage and endurance over pure efficiency, and that tradition would cost him everything. Amundsen's approach to the journey was almost ruthless in its practicality. He used dogs, lots of them, 52 Greenland Huskies organized into teams trained to pull heavy sledges across snow and ice. And here is the detail that most retellings soften or omit entirely. Amundsen's plan included feeding the weakest dogs to the stronger ones, and eventually to the men themselves as the journey progressed. This was not cruelty. This was mathematics. Every dog that was eaten reduced the amount of food that needed to be carried forward. The dogs were simultaneously the engine and the fuel supply.
Scott, by contrast, relied heavily on Siberian ponies for his transport, supplemented by motorized sledges, a new technology, and man-hauling, which meant the explorers themselves pulling their sledges by brute physical effort. The motorized sledges broke down within days of leaving base camp. The ponies, poorly suited to Antarctic conditions, struggled in the cold and had to be shot before reaching the trans-Antarctic mountains. From that point, Scott's team was man-hauling across some of the most brutal terrain on Earth. Amundsen's team reached the South Pole on the 14th of December, 1911. They planted the Norwegian flag, pitched a tent, left a letter for Scott inside it, a letter that was simultaneously gracious and devastating. and turned around and walked home. Every man survived. They returned to their base camp in good health, with surplus food remaining. Scott's team reached the South Pole on the 17th of January 1912. 34 days later, they found the Norwegian flag already there. Scott wrote in his diary that night, and the words have become some of the most quietly heartbreaking in the English language. "Great God, this is an awful place, and terrible enough for us to have labored to it without the reward of priority." The return journey killed them. Weakened by the effort of man-hauling to the pole, short on calories, battered by an unusually severe Antarctic autumn, Scott's team of 5 began to fail one by one. Edgar Evans collapsed and died first, near the Beardmore Glacier. Lawrence Oates, whose feet had become so severely frostbitten that he could barely walk, and knew he was slowing the others, walked out of the tent into a blizzard one night and never came back. His last words, spoken to his companions as he left, were recorded by Scott as simply, "I am just going outside, and maybe some time." Scott, Edward Wilson, and Henry Bowers died in their tent, trapped by a blizzard just 11 miles from a supply depot that could have saved their lives. Their bodies were found 8 months later, with Scott's diary beside him, still being written almost to the end. What the history books often understate is how close Amundsen's success and Scott's tragedy were to being reversed. Amundsen took risks too, calculated ones. If a single key decision had gone differently, if the weather had shifted on a crucial day, the outcome could have been entirely different. The 34 days between them were the product of thousands of individual choices, stretching back years before either man set foot on the ice. Amundsen won because he trusted the dogs and understood the cold on its own terms. Scott lost because he trusted technology that failed and an ideology of human endurance that the Antarctic cold simply did not respect. The ice does not care about courage. It never has.
Chapter 6: Operation Highjump and the Secrets Below.
There is a particular category of historical event that sits in an uncomfortable middle ground, too well documented to be dismissed, too strange in its details to be fully explained, and too quietly forgotten by mainstream history to have ever received the scrutiny it deserves. Operation Highjump is one of those events, and tonight we are going to look at it carefully, honestly, and without the distortions that both the conspiracy theorists and the determined skeptics tend to apply to it. The year was 1946. The Second World War had ended just 1 year earlier. The world was exhausted, reorganizing itself, and already beginning to feel the first cold currents of what would become the Cold War. And in this particular moment, this strange, tense, unsettled pause in history, the United States Navy launched the largest military expedition ever mounted to Antarctica. It was called Operation Highjump, and its scale was extraordinary. 13 ships, including an aircraft carrier, the USS Philippine Sea, 25 aircraft, submarines, icebreakers, a dedicated aerial photography unit, and approximately 4,700 men. This was not a scientific research mission with a military escort. This was a military operation with a scientific component. The distinction matters. The official stated objectives were reasonable enough on their face. The Navy said the operation was intended to establish the American claim to Antarctic territory, to train personnel in cold weather operations, to test equipment in extreme conditions, and to conduct aerial surveys of as much of the continent as possible. All of these things did in fact happen.
The expedition photographed approximately 70% of the Antarctic coastline from the air, an enormous cartographic achievement. But the operation ended early. It was scheduled to last 6 to 8 months. It lasted less than 2. The official explanation was that the Antarctic weather had been worse than anticipated, and that sea ice conditions had made continued operations too dangerous. This explanation is not impossible. Antarctic weather is genuinely brutal and unpredictable, but historians who have studied the expedition closely have noted that the sudden withdrawal was never fully explained in the detail one might expect from an operation of this size and cost. And then there is Admiral Richard Byrd. Byrd was the most famous American polar explorer of the 20th century, a genuine national hero who had led multiple Antarctic expeditions before the war. He commanded Operation Highjump, and after returning from it, he gave an interview to a Chilean newspaper, a quote that has been repeated, misquoted, and argued over ever since.
In that interview, Byrd said that the United States needed to be prepared for the possibility of an attack coming from the polar regions. He spoke of aircraft that could fly from pole to pole with tremendous speed. He described Antarctica in terms that suggested it posed a strategic concern, not merely a geographical one. The interview, translated and reprinted, caused a quiet stir among those paying attention. What exactly did Byrd mean? Here is where the honest answer requires separating several layers. The most straightforward interpretation is that Byrd was speaking about the emerging Cold War threat, the possibility that the Soviet Union might use polar routes for aerial bombardment of North America, which was a genuine and serious strategic concern of that exact era. The polar route from Russia to the United States across the Arctic is significantly shorter than any other flight path. This was not paranoia. It was basic geography, and American military planners were actively discussing it.
But a secondary interpretation, one that has fueled decades of speculation, suggests that Byrd was hinting at something encountered in Antarctica itself. The theories range from the plausible to the extraordinary. Some researchers have pointed to the fact that several German expeditions visited Antarctica before and during the war, including the 1938 Schwabenland expedition that claimed a large section of the continent for Germany and named it Neuschwabenland. Wartime rumors, never confirmed, suggested that Germany had established a secret base in Antarctica and that Operation Highjump may have been partly intended to locate and neutralize it. There is no confirmed evidence of a German Antarctic base. There is no confirmed evidence that Operation Highjump encountered anything other than ice, weather, and the logistical nightmare of operating at the bottom of the world. What there is a genuine and unresolved gap between the scale of the operation, its abrupt early ending, and the complete official explanation that was offered for both.
The classified portions of Operation Highjump's records were not fully released for decades. Some reports suggest that certain aerial photography taken during the mission was classified and never made fully public. Why aerial photographs of empty Antarctic ice would require long-term classification is a question that has never received a fully satisfying answer. What is certain is this: after Operation Highjump, American interest in Antarctica accelerated rapidly. Within a decade, the Antarctic Treaty was being negotiated. Permanent research stations were being established. The continent that had been largely ignored for a century suddenly became the focus of sustained, serious international attention. Something changed. Whether it was the Cold War calculus, the cartographic value of what the expedition photographed, or something else entirely,
something shifted in how the world's major powers thought about Antarctica after 1946. And the record of exactly what caused that shift remains, even now, incompletely told. Chapter 7: The Antarctic Treaty and the World Below the Agreement.
There is a particular kind of document that shapes the world, not just through what it says, but through what it carefully, deliberately chooses not to say. The Antarctic Treaty of 1959 is one of those documents. It is, on its surface, one of the most elegant and idealistic agreements in the history of international relations. And beneath that surface, it is a study in strategic ambiguity, a document that resolved some questions permanently and left others in a state of studied, intentional vagueness that continues to this day. To understand how remarkable the treaty is, you have to understand what the world looked like in 1959. The Cold War was at its most brittle and dangerous. The Soviet Union had launched Sputnik just 2 years earlier. Nuclear testing was accelerating on both sides. 7 different nations, Argentina, Australia, Chile, France, New Zealand, Norway, and the United Kingdom, had made overlapping, competing, and in some cases mutually exclusive territorial claims to portions of Antarctica. Several of these claims overlapped directly with each other, particularly those of Argentina, Chile, and Britain in the Antarctic Peninsula region, which had already produced real diplomatic tension and at least one minor confrontation between naval vessels.
And yet, in this atmosphere of global suspicion and competition, 12 nations sat down together and produced a treaty that has held, largely intact, for more than 60 years. That is genuinely extraordinary. More nations have signed it since. There are now over 50 signatories, and the core provisions have never been fundamentally violated in any publicly documented way.
So what does the treaty actually say? The core provisions are straightforward. Antarctica is to be used for peaceful purposes only. Military activities, including the establishment of military bases, the testing of weapons, and military maneuvers, are explicitly prohibited. Nuclear explosions and the disposal of nuclear waste in Antarctica are banned. Scientific research is to be freely conducted and the results openly shared. All territorial claims are frozen, neither recognized nor formally abandoned for the duration of the treaty. That last provision is the quietly ingenious one. The territorial claims did not go away. Argentina still believes it owns a portion of Antarctica. So does Chile. So does Britain. So do 5 other nations. The treaty did not resolve those claims. It simply put them in a kind of suspended animation, asking all parties to agree to disagree indefinitely, while cooperating on everything else in the meantime. It was a diplomatic sleight of hand of the highest order, and it worked. But here is what the treaty does not say. It does not prohibit scientific research stations from being built to a size and specification that would in any other context be described as military infrastructure. Several nations have built research stations in Antarctica that are, by any practical measure, small cities. The United States McMurdo Station can house over 1,000 people. It has a fire station, a power plant, a water distillation facility, multiple laboratories, a harbor, and an airfield capable of handling large cargo aircraft. Russia's Vostok Station, China's Kunlun Station,
all of these represent substantial, permanent, strategically significant presences on the continent.
The geopolitical temperature beneath the frozen cooperation of the Antarctic Treaty is, if you know how to read it, quietly rising. Multiple nations are jockeying for position in a landscape that currently cannot be owned, but may not always remain that way. The treaty contains a provision that allows any signatory to call for a review conference after 1991. No such conference has ever been formally convened, but the conversation about what Antarctica's future governance should look like as the ice melts, as the resources beneath it become more accessible, as the strategic value of the continent in a warming world becomes clearer, that conversation is already happening in quiet rooms in capitals far from the ice.
Chapter 8: Lake Vostok, the ocean trapped in darkness.
Somewhere beneath the ice of East Antarctica, directly below Russia's Vostok station, there is a lake. Not a small lake, not a shallow pool of meltwater trapped in a depression in the rock. A lake the size of Lake Ontario, one of the Great Lakes of North America. A body of liquid water approximately 250 kilometers long, 50 kilometers wide, and in places over 800 meters deep. A lake that has been sealed in complete darkness under 2.3 miles of ice for somewhere between 15 and 25 million years. Its name is Lake Vostok, and it may be the most scientifically significant body of water on the surface of this planet.
The story of its discovery is itself remarkable. Scientists had suspected that liquid water might exist beneath the Antarctic ice sheet as far back as the 1970s. The ice is so thick and the pressure it exerts on the rock below so immense that in combination with geothermal heat rising from the Earth's interior, the conditions at the base of the ice sheet can actually cause the lowest layers of ice to melt. This is called subglacial melting, and radar surveys of the ice had begun to show anomalies, flat, reflective surfaces far beneath the ice that looked very different from solid rock. In 1996, a joint analysis of airborne radar data and satellite altimetry, measurements of the subtle variations in the surface of the ice above, confirmed what the data had been suggesting for years. Lake Vostok was real. It was enormous, and it had been sitting there, undetected, beneath one of the most studied regions of Antarctica for decades of scientific work.
The Russian drilling program at Vostok Station had actually been drilling toward it unknowingly since the 1970s. The Ice Core project at Vostok was one of the most important climate science programs in history. The cores extracted from that drilling gave scientists a continuous record of Earth's atmosphere going back 420,000 years, preserved in bubbles of ancient air trapped in the ice. Temperature records, carbon dioxide levels, volcanic events, all of it archived in the ice above the lake. But the drilling stopped repeatedly as the scientific community grappled with an extraordinary ethical and scientific question. If they broke through the final layer of ice into the lake itself, they risked contaminating an ecosystem that had been isolated for millions of years with microbes from the surface world. The contamination could be catastrophic, not to humans, but to whatever was living in that darkness below.
Because the working assumption, supported by substantial indirect evidence, is that something is living down there. Life, it turns out, is far more stubborn and creative than scientists once believed. In the decades since the discovery of Lake Vostok, researchers have found living organisms in environments that were previously considered completely uninhabitable. Bacteria living in the hyper-acidic water of volcanic lakes, microbes thriving in the boiling water of deep-sea hydrothermal vents, organisms surviving in the crushing darkness of the deep ocean floor, kilometers below any sunlight. Life has colonized essentially every liquid water environment on Earth, regardless of temperature, pressure, acidity, or darkness.
Lake Vostok has liquid water. It has dissolved minerals from the surrounding rock. It has geothermal heat from below. By every analogy we have, it should support life. And the ice cores drilled just above the lake, the accretion ice, formed when lake water freezes onto the base of the glacier above it, have already yielded something remarkable. Embedded in that accretion ice, researchers have found fragments of DNA and what appear to be remnants of microbial life. The analysis of these samples has been contentious, with some scientists arguing contamination from the drilling process, and others arguing the signatures are genuine. The debate continues. In 2012, Russian scientists finally broke through to the lake's surface. The drilling fluid used to prevent the borehole from collapsing was sucked down into the lake by the pressure differential, and lake water rushed up into the borehole and refroze. Samples of that refrozen lake water were analyzed. Results were, again, contested, with claims of novel bacterial DNA met by counterclaims of contamination. The science remains genuinely unresolved.
But the reason Lake Vostok matters beyond Antarctica, the reason it has captured the imagination of astrobiologists and space scientists as much as glaciologists, is what it represents as an analog. Jupiter's moon Europa is covered in a shell of ice. Beneath that ice, scientists are virtually certain lies a global ocean of liquid water, kept liquid by tidal heating from Jupiter's enormous gravitational pull. Saturn's moon Enceladus has a subglacial ocean that actually vents liquid water into space through geysers, confirmed by the Cassini spacecraft. These are not hypothetical oceans. They are real. If life can survive in Lake Vostok, if organisms have been living in cold, pressurized, lightless liquid water for 15 million years, fed by nothing but chemical reactions and geothermal energy, then the case for life in the oceans of Europa and Enceladus becomes dramatically stronger. Lake Vostok is not just an Antarctic curiosity. It is a test case for life in the universe. What lives in the darkness beneath the ice may tell us whether we are alone.
Chapter 9: The Anomalies. Things that still have no explanation.
There is a difference between a mystery and an anomaly. A mystery is something we do not yet understand, but feel confident we eventually will. An anomaly is something that sits outside our current frameworks entirely. Something that doesn't fit the models we have built, that resists the explanations we reach for, and that remains stubbornly, quietly strange no matter how carefully we look at it.
Antarctica has mysteries, but it also has anomalies. And tonight, we are going to walk through them slowly, one by one, with honesty and care, neither inflating them into proof of the impossible, nor dismissing them with the false comfort of incomplete explanations. The first, and perhaps most visually striking, is Blood Falls. In the Taylor Glacier of the McMurdo Dry Valleys, there is a waterfall that runs red. Not occasionally, not at certain times of year, but continuously. A slow, viscous, deeply crimson flow, seeping from a crack in the glacier's face and pooling on the ice below. When geologists first encountered it in 1911, they assumed it was red algae coloring the water. That explanation held for nearly a century. Then, in 2003, researchers discovered the truth, which turned out to be stranger than the algae theory.
Beneath the Taylor Glacier, sealed by the ice above it, lies a small pocket of ancient salt water, estimated to be around 1.5 million years old. This brine is so salty, it remains liquid at temperatures far below the normal freezing point. It is rich in iron, and it is home to a community of microorganisms that have been living in complete darkness, without oxygen, without sunlight, for an estimated 1.5 million years old, metabolizing sulfate and iron in a closed chemical loop that has sustained them through ice ages and warming periods alike. When this brine seeps to the surface through cracks in the glacier, the iron in it oxidizes instantly on contact with air, rusting, essentially, in the same way a nail rusts, and turns the water a deep, vivid red. Blood Falls is not supernatural, but it is a window into a form of life so ancient and so isolated that it challenges almost every assumption we make about what living things need to survive.
The second anomaly is the warm water beneath the ice. Antarctica is, in scientific understanding, a continent sitting on geologically stable ancient rock, what geologists call a craton, one of the oldest and most stable pieces of continental crust on Earth. And yet seismic surveys and ice-penetrating radar have revealed that beneath portions of the West Antarctic ice sheet, the rock is significantly warmer than it should be. In some areas, geothermal heat flux measurements are comparable to regions of active volcanoes. There are identified subglacial volcanoes, over 100 of them mapped beneath the West Antarctic ice sheet, making it one of the largest volcanic regions on Earth by count, though most are dormant or only minimally active.
But in certain regions, the heat is higher than dormant volcanism easily explains. The Pine Island Glacier region, for instance, which is also the fastest melting glacier in Antarctica, sits above an area of anomalously high geothermal heat. The debate over how much of Pine Island's accelerating melt is due to climate change and how much is due to geothermal heating from below is ongoing, and the answer has significant implications for sea level rise projections worldwide.
The third anomaly is the sound. In 1997, a team of scientists monitoring underwater acoustics in the Pacific Ocean recorded an extraordinarily powerful and extraordinarily strange sound. It was detected by hydrophone arrays thousands of kilometers apart, which meant the sound source was enormous, the largest sound ever recorded in the ocean up to that point. The scientists named it the bloop.
Its frequency profile and amplitude were unlike any known geological or biological source. The official explanation, arrived at years later, is that it was the sound of a very large iceberg fracturing and grinding against the seafloor somewhere in the Southern Ocean near Antarctica. This explanation is now widely accepted by the scientific community, but for years, the bloop remained genuinely unidentified, and the original recordings, with their strange, almost organic quality, continue to circulate and unsettle people who hear them for the first time.
The fourth anomaly is less dramatic, but in some ways more persistently strange. It is a geometric feature, a precise, almost perfectly square iceberg that broke off the Ross Ice Shelf in 2018 and was photographed from the air by a NASA survey aircraft. The right angles were so exact, the flat surfaces so uniform, that the images went briefly viral online, with many people refusing to believe a natural process could produce such a shape. Glaciologists explained patiently that tabular icebergs, formed by the calving of flat ice shelves, can indeed produce very regular rectangular shapes along natural fracture lines in the ice. The explanation is correct and scientifically sound, but the image remains visually arresting in a way that makes the explanation feel almost insufficient. A reminder that nature can produce things that look, to human eyes, almost deliberately constructed.
And then there is the fifth anomaly, the one that is least discussed and most quietly unresolved. It is a large subglacial structure detected by airborne radar surveys sitting beneath the East Antarctic ice sheet in Wilkes Land. It is approximately 300 kilometers across. It is roughly circular, and it creates a gravitational anomaly, a measurable distortion in the local gravitational field that has been confirmed by multiple independent surveys. The leading scientific hypothesis is that it is the remnant of a massive meteorite impact crater, potentially the largest impact crater ever identified on Earth, from an impact that may have triggered the largest mass extinction in Earth's history, the Permian extinction event of 252 million years ago, which killed over 90% of all marine species and over 70% of all terrestrial vertebrate species.
This hypothesis has been proposed in peer-reviewed literature. It has not been confirmed. The ice above it is too thick to allow direct drilling investigation with current technology. And so, the Wilkes Land anomaly sits beneath its 2 miles of ice, a vast, circular, gravitationally distinct structure at the bottom of the world, and waits. Antarctica keeps its secrets with the patience that only ice and deep time can sustain.
Chapter 10: What Sleeps Beneath. The Future of the Frozen Continent.
There is a particular quality to the light at the end of a long journey. It is softer somehow, less demanding. It asks nothing of you except that you be present for it, that you allow yourself to arrive. And tonight, after everything we have traveled through together, the ancient philosophers and their imagined continent, the impossible maps, the brutal races across ice, the secret operations and frozen lakes and bleeding glaciers and ancient anomalies, we have arrived at the edge of something that is not the past at all. We have arrived at right now. And right now, Antarctica is changing.
The numbers are not comfortable ones. The West Antarctic ice sheet is losing ice mass at a rate that has roughly tripled since the 1990s. The Pine Island Glacier and the Thwaites Glacier, sometimes called the Doomsday Glacier by scientists who are usually careful with their language, are retreating at speeds that were not predicted by the models of even 15 years ago. The Thwaites Glacier alone holds enough ice that its complete collapse would raise global sea levels by approximately 65 centimeters. And the processes now underway beneath it, the warm water intrusion, the geothermal heating, the loss of the ice shelf that acts as a buttress holding the glacier in place, are, by the assessment of most glaciologists who study it, already beyond the point of easy reversal.
But the melting is not only a crisis, it is also, in the most complicated and morally ambiguous way, a revelation. Because as the ice retreats, it exposes things. It uncovers coastlines that have been buried for thousands of years. It reveals rock faces and valleys and lake beds that no human eye has ever seen. And it releases things that were sealed inside the ice. Some of them beautiful, some of them merely ancient, and some of them deeply, quietly concerning.
In the permafrost regions of the Arctic, scientists have already documented the re-emergence of ancient pathogens. In 2016, a thawing patch of Siberian permafrost released anthrax spores that had been frozen for 75 years, the remnants of a reindeer that died during an anthrax outbreak in the early 20th century. The spores infected reindeer, and one child died. In 2021, researchers revived a 24,000-year-old microscopic organism called a beetalloid rotifer from Siberian permafrost, an organism that had been frozen since the last ice age and resumed swimming and reproducing when thawed.
Antarctica's ice is older than Arctic permafrost, much older. The ice at the base of the East Antarctic ice sheet in some regions is estimated to be over 1 million years old. What is sealed inside that ice? What viruses? What bacteria? What biological material from ages before human civilization is largely unknown? The scientific consensus is cautious, but not alarmist. Most ancient pathogens require a living host to cause disease, and would be unlikely to find one after millions of years of isolation. But the honest answer is that we do not know with certainty. The ancient biosphere preserved in Antarctic ice has barely been studied.
Beneath the retreating ice, something else is also being revealed. Resources. Antarctica is estimated to contain significant deposits of coal, iron ore, copper, gold, and rare earth minerals critical to modern technology. The Antarctic Treaty's Protocol on Environmental Protection, signed in 1991, established a 50-year moratorium on mineral extraction that runs until 2048. After 2048, the protocol can be modified if 3/4 of the treaty's consultative parties agree. The conversations about what happens in 2048 are already beginning, quietly, in the margins of international meetings.
China has been explicit in its Antarctic policy documents about its interest in the continent's resources. Russia has been equally clear in its resistance to any treaty modifications that would constrain its freedom of action in the region. The United States has been characteristically cautious in its public statements, while steadily expanding its own research infrastructure. The diplomatic architecture that has kept Antarctica peaceful
and cooperative for 60 years, is not yet under serious threat. But the pressures building against it, geopolitical, economic, environmental, are real and measurable.
And then there is the deepest question, the one that science fiction has asked for decades, but that serious researchers are now beginning to approach with genuine tools and genuine seriousness. What if we find something truly unexpected? Not ancient bacteria, not fossilized forests. Something that genuinely does not fit the story we have been telling ourselves about this continent and about the history of life and intelligence on this planet.
The Wilkesland anomaly sits beneath its ice, unmeasured. Lake Vostok holds its secrets in lightless water. The subglacial mountain ranges hidden beneath the East Antarctic ice sheet, some of them taller than the Alps, completely invisible from the surface, have been mapped by radar but never seen by human eyes. The oldest ice on Earth, which scientists are currently drilling toward in a project called Beyond Epica, will yield air bubbles containing atmosphere from 1.5 million years ago, a direct chemical record of a world before our species existed.
We do not know what is down there. That is not a failure of science. That is simply the honest position of human knowledge at this particular moment in history. We have mapped the surface of Mars in greater resolution than we have mapped the bed of the Antarctic ice sheet. We know more about the far side of the moon than we know about what lies beneath the oldest ice on Earth.
Antarctica has been keeping its secrets for a very long time. The philosophers named it before they knew it existed. The explorers found it and were nearly destroyed by it. The nations of the world agreed to share it and then quietly competed for it anyway. Its ice holds the memory of climates we never lived through. Its lakes may hold life that has never seen light. Its depths hold structures we cannot yet explain and resources we have not yet agreed how to handle.
And tonight, at the end of this long journey, as your breathing slows and the weight of the day lifts gently from your shoulders, Antarctica is still there, still frozen, still vast, still keeping its deepest secrets in the only vault that has ever proven truly secure. 2 miles of ancient ice pressing down in silence at the bottom of the world. Let it keep them for a little longer. There is time. There is always, in the deep story of this planet, a little more time. Rest now. The ice will still be there in the morning, cold and patient and full of everything we have not yet thought.